All right, in this video, we are going to talk about the slope of a line. All right, so the situation is that we have, clear this off here. The situation is that we are in the plane, right, the Cartesian coordinate system, and we have a line that we draw like this, okay? So the graph is a straight line, and it's not a vertical line, let's say. Okay, so the thing is if you take any 2 points, right, that are on that line, and think about a little triangle that looks like this. All right, if you take the length of this side of the triangle and then divide by the length of this side of that little triangle, then it always comes out to be the same no matter where you pick those 2 points. So I might pick 2 points down here, okay, and on that are on the line, and I might make this little tiny triangle, right? And the sides of this triangle are going to be a lot smaller than the sides of this triangle right here. But if I take the length of this side and divide by the length of this horizontal side, it's going to be exactly the same as what I get over here, okay? And that happens again. It doesn't matter how far away you pick the points, how close together you pick the points. As long as you pick two different points, right, and calculate that out, you're going to get the same number every single time, okay? And so that number is called the slope of the line, all right? And the slope of a line tells you something about the line itself, okay? So um, uh, the slope, if it comes out to be a number, right, that number would either be a positive number, okay, or 0, or a negative number. All right, and if that number is positive, then your line is going to be going up as you go from left to right. So a line with positive slope will go up as you go to the right. And the bigger that positive number is, right, the steeper the slope of the line is. If the slope of the line is 0, that means it's going to be a perfectly horizontal line like this. That's slope 0. And if the slope is a negative number, that means that the line is going to be going down as you go from left to right. Okay. So the slope of a line can tell us quite a bit about the way the line looks. There is one case here that we haven't talked about, and that's the case of a vertical line, right? With a vertical line, vertical lines have undefined slope. Okay. So going back over here, we see what we want to be able to do is to calculate the slope of a line that contains 2 points, x1, y1, and x2, y2. So this formula over here, and m is the traditional variable that's used for slope, right? And you can see the formula is if I have 2 points, x1, y1, and x2, y2, then the slope formula is y2 minus y1 over x2 minus x1. So the way that looks is, if I draw this out, so here is my line, and here are my points on here. So let's say this is x1, y1. And this is x2, y2. right? I can make this little triangle like so. All right, so there's the little triangle. And then now the length, right, of this side of the triangle is going to be this y coordinate minus this one. So it's going to be y2 minus y1. All right, and for this side of the triangle, right, that's going to be this this number x2 minus x1. So basically, right, x2 minus x1, this side of the triangle is how much the x value changed from this point to this point right here. And y2 minus y1 is going to be how much the y coordinate has changed going from this point to this point right here. All right, so that's why the formula is y2 minus y1. That is the change in y, right? And then you put that over x2 minus x1, that will be the change in x. So you'll see and hear people refer to the slope as the change in y over the change in x, and that's exactly what it is. How far did you go from here to here? One real world scenario where that is important is in roofing, right? When you go to cover a roof with shingles or some other cover like that, then it's important to know the pitch, right, of the roof. That's what they call it in roofing, the pitch, instead of the slope. But in algebra class, we call it the slope. So they have to make this same calculation, right, in roofing. Okay, so next up, let's do that. Let's actually go ahead and close that one out. We don't need that anymore. And calculate the slope. Okay, so in this example, what we want to do is to calculate the slope of the line that contains the points 4, comma, minus 3 and 2, 7. So 4, negative 3 and 2, 7. So I've calculated those out right here. And so this green line goes through 4, negative 3 and 2, 7. Right? So there's the line. And what we want to do is calculate the slope of that line. All right? Okay, so what you would do is to label one of these points x1, y1, and label the other one x2, y2. All right, and again, it does not matter. I could have labeled this point as x1, y1 and this point as x2, y2. So you don't have to worry about any of that. I have the slope formula, and I like to label my... Whoa, man. All right, hopefully that's still recording. That was a huge lightning strike nearby. Okay. So the slope formula, right, is y2 minus y1 over x2 minus x1. And since I have my points labeled, right, I can just easily pick off the numbers that I need, right? So y2 is 7. y1 is negative 3. So that would go on the top. And then x2 is 2 minus x1, which is 4. All right. Okay, and so now we would just simplify this as much as possible. So right here we have subtracting a negative, right? So remember, you can always rewrite that as addition, right, by adding the opposite. Change the subtraction to addition, and then change the sign of the number here. So 7 minus a negative 3 is the same as 7 plus a positive 3, and we know that comes out to be a 10. All right, and then 2 minus 4 would be negative 2. And then we would need to reduce this fraction as much as possible. 10 divided by a negative 2 is a negative 5. So the slope of this line is negative 5. And we can kind of see that in the picture, right? Let me get it so that you can draw on that. Okay, so again, what we've done here is we made this little triangle from here to here. And then when we made that calculation, on top of the fraction we had 7 minus a negative 3, right? So 7, right, was this point right here, 7. And negative 3 was right here. So we did 7 minus a negative 3. And really what we were calculating there was how far is it from negative 3 to 7. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of this side was 10. And then over here, right, what we did, sorry, that should, over here what we did, yeah, that's what we got on 10. You could do it the other way as well. So just to illustrate, so down over here what we did was we went from 2 to 4, right? And the way we had our points labeled, we did 2 minus 4, right? Which is minus 2. Okay? So we calculated that to be minus 2 in here. That's by the way that we labeled the points, right? And then we divided these two sides together and got 10 divided by minus 2, right? That's how our calculation went over here. So we had the positive 10 on top and minus 2 on the bottom. Like I said, you can label these points any way you like, and so that's why our calculation came out like that. But really what it's saying here really is that the y value, it dropped from 10 to minus 3, right? So geometrically, the other way, the labeling the other way probably makes a little more sense, right? But hopefully you can see, you know, how we came about that, right? So we got minus 5 in there, right? So there I'm just trying to illustrate, you know, the calculation that you're actually making there. All right, so I think that's it for this slope video. Let's just double check to see. Yes. And using the formula is pretty straightforward. And just to kind of show you where we're headed towards, right, we're headed towards finding the equation of lines. You can see that I have the equation right here for this green line, y equals minus 5x plus 7, right? And it's no coincidence that the number with x is negative 5, which is our slope, okay? And so this is something called the slope-intercept form of a line, and that number with the x in the slope-intercept form is the slope of the line. All right, that's it for this one.